Word of the day. Word of the day. Today's word of the day is power. A base and an exponent is referred to as a power. So here we see the power of 4 to the third. The base, a value multiplied by itself a fixed amount of times here, is 4. And the exponent, the number of times a base will be multiplied, is 3. Now, we've been dealing with scientific notation and powers of 10. And here we had an example of multiplying with scientific notation. And in the example, they multiplied the powers of 10, right? So here we see two expressions, one that has times 10 to the fifth and the other that times 10 to the third. So in parentheses, they did 10 to the fifth times 10 to the third. And the note we made here was that you add the exponents. In addition to this example, we also looked at the Krusty Krab problem here, right? Where part A was how many people in total are served. And so we had multiplied the numbers given there. And when doing so, we put the coefficients in one set of parentheses. And again, here we see the powers of 10 being multiplied, where again, we add the exponents. Now, you guys know I'm a fan of Disney. This is from Frozen here. You see a baby Sven, which is a caribou or a reindeer. And here he is kind of grown up. What I like about this picture that Disney did is that it is true to form. This is from National Geographic. So that is roughly the size of what adult caribou would be. Here's a caribou fact. An adult caribou weighs 2 to the 6 times more than a newborn who weighs 2 to the third pounds. So if I was to figure out what's 2 to the 6 times more than 2 to the third, here you can see I'm multiplying those two powers here that have the same base as 2 but different exponents. And so using different colors, you can see I wrote what we call expanded form. That's the repeated multiplication shown here. So there are 6 2's here and 3 2's here, right? So that's a total of 9 2's that we got. So I could write this as 2 to the ninth, right? You can also think about this as just add in the exponents. So this is called the product of powers rule. For any number a and all integers m and n, you can write that as just the m plus n here, right? Where you're adding the exponents. And this is only if you have the same base. So here you can see example, we have 3 squared times 3 to the third, right? And so they're just going to add the exponents to write it as a power of 3 here, 3 to the fifth, right? And you could check that. 3 squared is 9, 3 to the third is 27. So would 9 times 27 still come out to be 3 to the fifth here? Here it's done with just a variable, x. So even if we don't know what this number is, again, you can add the exponent, and this would be x to the 6. Okay. Now, in addition to multiplying, we had also divided. We'd found the population density of Massachusetts by dividing the population by the area here. You might remember where we just divide the coefficients and then subtracted the exponents. So here's another example where this time, instead of dealing with powers of 10, I have 6 to the fifth divided by 6 to the third, right? So I'm going to write that as a fraction. And if I have 5 sixes on the top and 3 sixes on the bottom, now remember, if I'm just dividing a number by itself, it comes out as 1. So you can see how the 3 sixes on the bottom, I can match that up with 3 sixes on top. And I would just be left with 2 sixes, or 6 squared. This is called the quotient of powers property, which states that when dividing two exponential expressions with the same base, you can subtract the exponents, right? So here we see a non-zero number a, right? And any integers x and y, right? If the base is the same, then you can write the exponents just being subtracted. So if I had a base of b, right? B to the fifth over b to the third, you can subtract those exponents. So in summary, right? Here we have z to the fifth times z to the third. This would be if it was expanded form, right? z to the 8th. I don't have to write out all those z's. I just know that 5 plus 3 is 8 there. So when multiplying expressions with the same base, we can then add exponents as a shortcut. Same with division, right? If I had 5 z's on top and 3 z's on the bottom, I get z squared. So when dividing expressions with the same base, we can subtract exponents as a shortcut. Now, if you have coefficients like the ones in green here, right? Here again, we see all the x's expanded out. We have 7 here and 3 here. So exponents we add. So we had x to the 10th. The coefficients just get multiplied, right? They're just regular numbers. We got 4 and 2, so 4 times 2 is 8. Let's look at division, right? Here's 7x's on top, 3x's on the bottom. So 7 minus 3, we get x to the 4th there. And for the coefficients, we're dividing. It's just 4 divided by 2. All right.